Now I want to see some hidden behavior on this one. So let's put it in our calculator. I'm going to clear this out. I'm going to set my window, well, I'll clear it out. And I'm going to put x cubed minus 1.1x squared minus 65.4x plus 229.5. Pretty ugly equation to want to sketch by hand. So we're putting it in our calculator. I'm going to do zoom 6 so it will be in the regular mode. Now if you see, I crossed here, and I got to find out if I crossed here. Well, let's see. It's cubic. I should have 3 points, but I can't really tell if it touches or crosses. So let me calculate the first 0, which is this one here. We know it crosses there. Second, calculate 0. And now I have to move my point. I'm here on the 0, and I know this is over here. So I'm going to move this until I can see my cursor way up high, because I can tell on my y values. So I keep coming down. I need to come down quite a bit. Now this is negative, so that means I'm left. Now I want to see where it's positive. Now I got a positive, so I hit enter again, and I guess, and my first 0 is at -9. Now I want to know if that touches, so I'm going to go and zoom in, but I'm clear over here. So what I want to do is move my cursor over to there. So I keep moving my cursor. I can't see it right now, so I got to bring it down. And see my cursor? I need to zoom in over here. So I bring it down some more, bring it down some more, and now I'm going to zoom in over by where the 0 might exist. So let's zoom in and see what we get. Well, I didn't have it in the right spot because I don't see anything. So what I'm going to do is go back to zoom stat. This curve comes down here, 1, 2, 3, 4, 5. So I want to zoom in, and I need to be closer to my 5 on the x-axis. So let's see. I'm getting there. That's about where I want to be. I hit enter. And now this is going to graph. I still can't see it. It looks like it touches. So I'm going to zoom in again. Now I'm about right there, so I hit enter. Now it's really zoomed in, and you can see that it crossed. There are 2 zeros there. So what I'm going to do is second, calculate a 0. I need to be to the left, and then I need to be to the right. And I hit enter. My other 0 is 5. But I have another one there. Second, calculate 0. Now these two could have been found on the table, but this next one could not. So that's why you have to zoom in, because your calculator sometimes looks like it touches when it doesn't. See how close these two are? So you have to make sure you zoom in to get all the zeros. In the last problem we found 3 solutions. And we have been taught that if a polynomial is x cubed, it's going to have at most 3. Now we could have looked on that graph forever and not found any more, but that doesn't prove it. So throughout this, there will be some proofs that are shown. Will you have to do proofs? No. But I'm going to talk about it because a graph just gives you what you want to look for, but it doesn't prove anything. So what we want to do here is prove that 6 is a factor of this polynomial for every positive integer n. So what we did is we gave the first 9 values of n cubed minus n. So if we plug in 1, we get 0. If we plug in 2, we get 6. So 2 cubed is 8, minus 2 is 6. And that's where this data comes from. Now there are some divisibility rules that you need to realize. If a number is even, then 2 goes into it. If you add the numbers and the sum is divisible by 3, then 3 goes into it. On 4, it's the last 2 digits. If 4 goes into the last 2 digits, then it's divisible by 4. If it ends in a 0 or a 5, then it's divisible by 5. 6, if both 2 and 3 go into it, then it's divisible by 6. 7 is an odd duck, you're just going to have to try it. There are some rules, but those are harder than just trying it. 8 is the last 3 digits. If 8 goes into the last 3 digits, then it's divisible by 8. And 9, if 3 goes into it, a 9 may or may not, but you have to look at adding the digits up as well and seeing if the sum goes into it. You all know that 10, if it ends in a 0, 10 goes into it. So let's see what we have here in this proof. What we're going to do is, the proof says, let n be any positive integer. And let's factor our polynomial. Factor n cubed minus n. So when I factor that, I get n squared minus 1, which factors down to n plus 1 and n minus 1. Now, if we think about this, what is this? Well, if I have an integer, n, so let's say, for example, if I have an integer, let's say 3, n plus 1 is 4, n minus 1 is 2, so what we're looking at is this is 3 consecutive integers. So n plus 1 and n minus 1 is the product of 3 consecutive integers. And it doesn't matter what you start off n as. It could be 0, it could be 5. Alright, so now let's look at 3 is a factor. 3 is a factor of n cubed minus n. 2 is a factor. Okay? If I go over to here, do I got here? So we're telling you that 3 and 2 are a factor. And why is that? Because if I have 3 consecutive integers, right, 2, 3, and 4, it has to contain a multiple of 3 in there. Notice 3 is a multiple of 3. If I had 4, 5, and 6, so 3 is a multiple of 6. If I had 7, 8, 9, 3 is a multiple of 9. Now every other number is even. So if it's got every other number is even, 2 has to be a multiple of it as well. So now if I have 2 and I have 3, then 6 has to be a factor of it. Therefore, 6 is a factor. And that's because I have 3 and I have 2. And you keep going. If you did 12, 13, and 14, 12 is a multiple of 3 and 2 is a multiple of either one of these. So as long as they're positive integers, both 3 and 2 are going to be factors. And if that's the case, 6 has to be one as well.